So thank you very much. Thank you for your introduction. So let's go to the layout of this presentation. At the beginning, very short introduction. Next, short information about the structure which was analyzed. Next, few words about numerical model, which was about this model. My co-author Trong Chuc Nguyen will be talking a few words. Next, I will present the results. First of all, temperature changes, mean strains, strain gradient, self-equilibrated strains, and total strains. Finally, I present the conclusions. As everyone knows, during this conversation, the period of concrete hardening, i.e. of cement hydration, is the time when significant imposed strains occur in massive and semi-massive structures. And in the case of massive structures, for instance, in reinforcement concrete tanks, you have the biggest problem with the water tightness. So because the cracks causes leakage. And in these cases, we need to limit the crack width up to 0.1 millimeter. Moreover, we have a lot of parameters, a lot of data, and sometimes it's difficult to reduce the crack width or eliminate it. In the case of massive structures, one of the best solutions is the use of cooling pipe system, thanks to which the temperature rise resulting from cement hydration can be effectively lowered. In the case of semi-massive structure, in the literature, according to us, there is a lot of gaps. And that's why we decide to perform analysis and try in details show the effect of cooling pipe system on the temperature changes and imposed strains in semi-massive, not massive, but semi-massive wall of a reinforcement concrete tank. A detailed analysis of the effect of CPS on changes in stresses was already presented by me and by my co-author in the paper which is in reference. Today we will say only about strains. So the example which was analyzed is part of the external wall of a reinforcement concrete tank. We see the first part of this wall. It was constructed without this construction joint, unfortunately, and we see external cracks at the external and internal surface of this wall. The crack widths were about 0.2 millimeter, so there were very big problems with water tightness. So the length of the segment wall was about 30 meter, the thickness is 0.75 meter, and the height 1.4 meter. So the next part of presentation is about numerical model. This model was presented in the paper which is on the conference. However, it was presented in everyone can find it in forthcoming paper about which I mentioned before. Please, my co-author Trong Chuc Nguyen, to say a few words about this model.
Numerical models are changes in the temperature field in the wall containing CPS were categorized by solving two basic different equations. A Fourier equation taking into account a piece of hydration cement and equation taking into account the head transfer between CPS and concrete. You can see from the equation the convection boundary condition is expressed as the principle of heat transfer through the cooling to adjust the heat transfer from concrete to the cooling pipe through the pipe and many within the cooling pipe. To determine the pipe temperature, the pipe arrangements is assumed to consist of several pipes connected with one another. Each pipe is assumed to have length perpendicular to the calculation plane. The inlet temperature of each true T inlet and either outlet temperature T outlet or pi flow which must specify. The approximation is removed from the concrete use CPS as shown by equation number 4. Using thermal equilibrium, if the pi outlet temperature is specified, the energy required to arrange the cooling system is determined as you can see in equation number 5. If the heat energy that must removed from concrete is specified, the outlet temperature is determined by formula. Number 6. The ambient temperature is assumed as follows. Its main simplification was to perform calculation in 2D. The 2D finite element model to determine temperature is mass concrete structure with CPS were present in detail by Mariusz and Thiam. Possible difference may result from the heating of the flowing water. However, the obtained result is in this report should be transferred at atmosphere. Further to it just the FAM miss and numbering of the news for which the result of the calculation presented further is paper. The calculation take into account was the influence of the chilling ambient temperature as well as the thermoboundary condition in line within the technology of the construction in the ceramic. The present of framework and further ceramic work built on the foundation of it who assumes that the cross section equal to cooling pi at the height of 0.45 and 0.54 meters. The stars were designed using C2025 concrete. You can see table 1 characteristics of the pipe cooling system. Detailed description of the model is presented by just Anche.
So thank you for your part. Next, can you hear me?
Yes.
Okay, thank you. So let's see the results of temperature changes. On the left side, we have temperature changes in the variant without cooling pipe system. On the right side, with cooling pipe systems. Blue lines describe temperature changes at the level where the first cooling pipe was located, and red lines in the middle height of this wall. We can summarize that the temperature reduction is quite significant, but it strongly depends on the location of node according to the cooling pipe. For presented group of nodes, we see that the range of temperature reduction is between 8 and 34%. Next, we have calculated the mean temperature changes, not temperature, but temperature changes, mean for a given for individual ordinates of this wall, because sometimes, according to some standards, such data are required. We see strong reduction inside the wall. I forget, maybe this direction shows the temperature, the next one time up to 7 days, and the last one shows the height of the wall. Moreover, the temperature decrease in the wall section in the variant with CPS begins 5 hours earlier. Next, we show the first component of mean strains. The first line shows changes of mean strains in the variant without cooling pipe system, continuous line with CPS, and the almost dotted line shows the difference between those examples. We see that the highest difference is about 40% for the time 2 days. Moreover, since concrete creep takes the highest value in the period of positive strains formation, the restrained part of imposed strains of the variant with cooling pipe system will be definitely higher. And in the design practice, for instance, according to Eurocode, the period of positive imposed strains increase is disregarded. Therefore, on the basis of the comparison of strains after reaching Tmax only, it can be concluded that the internal cooling reduces the mean free strain of thermal shrinkage about 20%. Next component of strain is gradient. Again, on the left side, we have solution without cooling pipe system, on the right side with cooling pipe system. And in general, we see that the values are also smaller. Next, we see horizontal cross-section from previous figures, and in detail for selected time steps we can compare the values of strain gradient according to JSCE, degree of restraint for this construction rotation. Degree of restraint is 1. It means that 100% of these strains could cause stress gradient. The last component, self-equilibrated strains, again, left side with CPS and right side without CPS. We again see that inside the wall, the value of these strains are much smaller, and also at the bottom of this wall. When we compare the maximum value, we see that it is about 75 micro strain, and if we compare this value to the tensile strain capacity of maturing concrete according to Syria, it is about 70. It means that probably the cracks could appear only from the self-equilibrated strains. Now, again, we see the cross sections from previous figures, and we see strong reduction of strains at the bottom and top of this wall if we compare these values, and also in the places where cooling pipe were located. In the middle, of course, we have also reduction, but it's not so big. The presented strains component, I think about mean strain, strain gradient, and self-equilibrated strain occur simultaneously over the entire period of concrete maturing, but their extreme values are shifted in time. Consequently, the combined effect of these strains for the entire period of concrete maturing is required. That's why we calculate total strains for selected points of this extraction. On the left side, we see the results on the vertical edge of the wall, on the right side along the wall axis, and both solutions without and with CPS are presented. In general, can be stated that after 3 days, in the variant with CPS, the strains are smaller. It also means that the cooling intensity during the first 3 days should be limited by the possibility of the occurrence of premature tensile strain. Moreover, we saw that this curve starts from the maximum temperature. We don't take into account the temperature during its increasing to show the differences. Next, we have calculated the ratio between previous total strains, previous presented total strains for both variants, and we see that after 3 days, the maximum value is 50%. It is in the middle height of this wall, inside this wall. For the rest presented point of this structure, this reduction is limited up to 25%. So let's go to the conclusions. The first one, in reinforcement semi-massive walls, internal cooling reduces very effectively the temperature rise of maturing concrete only in the immediate vicinity of the cooling pipes. The temperature variation reduction in the other areas is definitely smaller, which might result in locally higher self-equilibrated stresses. Such situation didn't appear in our case. However, we know that such case could take place. The four cooling pipes spacing should be determined by inter-area local temperature changes in the wall section. The next one, in the process of concrete maturing, internal cooling contributes to a reduction of mean strain changes and strain gradient. In the analyzed semi-massive wall, the reductions are 18 and 35% respectively, which enables concrete cracking to be limited or eliminated. We have in a previous paper analyzed stresses, and we know that in the case of early age cracking, this solution eliminates the cracking. In long term, some small cracks could appear. The next conclusion, the analysis of self-equilibrated strains indicates that the application of CPS contributes to a reduction to zero of the positive compressive strain differences in the immediate vicinity of cooling pipe. Moreover, CPS helps reduce the extreme strain changes in the positive in the wall interior and negative in its corner. And the analysis presented herein provides a basis for further studies on the identification of the most effective optimal engineering solution employing internal cooling in semi-massive reinforcement tank wall, including changes of key parameters such as cooling pipe spacing, cooling rate, and duration of cooling. These parameters will be determined by inter-area the wall geometry, composition of concrete mixture, external condition, and expected results, i.e. complete elimination or merely limiting of the range of early age concrete cracking. And the last one, conclusion, CPS results in a significant reduction of thermal total strain after 3 days of concrete hardening. But during the first 3 days, however, CPS causes greater increments of these strains, hence the cooling intensity is limited by the possibility occurrence of premature tensile strains. So thank you very much for your attention.